All right, so we're going to look at some absolute value equations, and this week we are going to do just a week review on absolute value before we move on to our next unit. I feel that it's always a good chance to review that before we start heading into more equations. And I want to point out that absolute value equations will appear on the final exam for this semester. So we want to be paying attention to this. We will review it again at the end of the semester, but this is a very important concept that you will also be doing in part 2. So keep that in mind as we go through today's video. So absolute value, those are the bars, right? 2 bars around your number. What does it tell us to do? It basically tells us to make that number positive. So in technical terms, it is the distance from 0. Your distance from 0. Distance is always positive, okay? I would never say, oh yeah, I'm just going -5 miles up the road there. You wouldn't say that, right? Distance is always positive. So absolute value is in terms of distance. So what do we know that these bars do? Make whatever's inside the bars positive. If this 4, like this one, is positive already, you keep it positive. This one is negative inside the bars. We still make it positive. This is a positive 4 right here, but we have that -4 on the outside. So we have a negative answer because there is a negative left over on the outside, okay? So that's what we, in simplest terms, that is what absolute value tells us to do. It's a mathematical operation to drop the negative. So if I wanted to evaluate here, I have my expression, right? There's no equal sign here, so we're not solving. We're just simplifying. It tells me what the value of x is. So there's really no need for me to solve. I already know what x is. What does that mean? Every time I see x, I'm going to plug it into my equation using parentheses. So this is 2, absolute value, 3 minus, I'm going to plug in -2 here in parentheses. Plus, I know that this lady's notes, the pluses always look kind of weird. Okay, so then I can put -2 in parentheses here. That one wasn't as necessary because I only have x by itself, but whatever. So I have 2 on the outside. What can happen in here? This is 3 minus a -2, which is really plus 2. So 3 plus 2 is 5. Plus, what does this become? I have one number now remaining in my absolute value bars. I can get rid of these negatives, so maybe you can see it a little bit, or these parentheses. What do those bars tell me to do? Make it positive. So this is really plus a positive 2. Okay, so what does this happen? It's already a positive 5, so we just keep it a positive 5. What operation is happening between these two things? Well, they're being squished together. I don't have a little plus sign in between them like I did that expression. So this is really 2 times positive 5 plus 2. 2 times 5 is 10. 10 plus 2 equals 12. So notice how I'm just slowly working step by step, simplifying what's in the absolute values first. These things are being multiplied, slowly condensing until I get my answer. Okay, so let's try, I'll try a couple, and then you guys will try a couple as well. So I'm going to try the first one here, the second, and the last one. You guys will try 2 and 3 on your own. So it tells me what x, y, and z are. So remember, these are absolute value bars. I know it looks really weird because that kind of looks like a 1. It's not, I promise. So maybe I will kind of draw in the bars for us as well. Okay, so I have 10 minus absolute value bar 5, and then I'm plugging in z. Z is -3. Remember, we use parentheses here. Plus 3, absolute value bar. So we want to simplify what's in the bars first. Still following PEMDAS, kind of think of that as a group of parentheses. So what is 5 times -3? -15 plus 3. What is -15 plus 3? You can type that in. It's -12. Now that I have one number in my absolute value bars, I can drop it. So we have 10 minus this -12 now becomes positive, meaning I'm not going to write another negative in front of it. 10 minus 12 is -2. Okay, so then I'll try this next one. I have 3 absolute value. These are absolute values. Absolute value of z, which is -3, minus x, which is -1, plus 2 minus y, which is 2. And so let's simplify. We have 3, and then inside the absolute value, I have negative 3 minus a negative. That's really plus, so that's negative 3 plus 1, which is negative 2, plus, what's going on in here? 2 minus 2, that is 0, which really just kind of goes away, right? I don't need to write plus 0. That's nothing. The absolute value of 0 is still 0. So what happens here? I now have one answer or one number in my absolute value. I can change that to its positive. What operation is happening? These two things are being squished next to each other. That means multiplication. So this is really 3 times positive 2, which gives me 6. Okay, so go ahead and try those next ones, those last ones on your own. So I'll zoom in here. So go ahead and try this first one. And once you're done, you're going to put in your answer. And then I will quickly show you what you should have gotten. Okay, so we should have had negative 1 minus 2 plus 6. So negative 1 minus 2 is negative 3 plus 6. So we make that positive. 3 plus 6 is equal to 9. All right, then the next one, we should have had negative 2, y is 2 as well, plus x, which is negative 1, plus z, which is negative 3. So inside the bars, we have negative 2 times 2, which is negative 4. And then remember, we used to circle this. Plus a negative is really minus 1. This is, again, inside the bars. So then, again, plus a minus is really minus 3. So what do I have? Negative 4 minus 1. Negative 4 minus 1 is negative 5 minus 3. I now have one negative number inside my absolute value. I can drop the negative, make it positive. 5 minus 3 is 2. So hopefully you got those correct. All right. Now let's flip to the backside and we're going to solve an equation. And this is the practice that you're going to do today. So we're going to do all of these together. And then you are going to do 6 examples on your own for the rest of class. And that's all I have. So once you are done with those, then you can work on something else. So, and the examples that are going to be like the in-class practice are going to be these two that I have stars next to. But I want to remind us how to do some that are maybe a little bit more complicated than that. All right. So we have some steps here. We first need to isolate the absolute value expression. What does that mean? Remember, I used to say this is kind of like a house. If the house is not secure, meaning I have numbers outside of the house, I can't set up my 2 equations yet. I need to get rid of everything. I need to isolate. So we ask ourselves, this is the number outside of the bars. It doesn't matter if there's a number on the other side of the equal sign. We're good over here. I want to get everything on the same side as the bars onto the other side. So what's happening? It's being subtracted. So what operation should I do to move that to the other side? Hopefully you said add. So we want to add 3 to both sides. So I get x minus 5 equals 10. Now I can set up the 2 equations. And so here's the next step. One set for the positive value, one set for the negative value, right? Because I know that I can have both a positive 10 and a negative 10 plugged into that equation inside the absolute value, and I'm going to get the same answer because we know that if I have a negative or a positive number in there, it's still going to end up with a positive answer. So I can set my first equation to be the same, x minus 5 equals 10. The other one is going to be x minus 5 equals negative 10. And I like these because we can just do the same math to both examples. I'm going to add 5 to both sides. So I get x equals 15. Do the same thing over here, add 5. It's just that now I have negative 10 plus 5, which is negative 5. And you will not have to graph these on the activity, but we do want to graph them here. Remember, we always put the smaller number first. We're doing a number line, so the negative 5, then the 15. And we can just plot those points there on the number line. We did this more for the inequalities. I don't think we ever graphed our answers on a number line for an equation. We'll do it. That's it. That's really all we have to do, so I'm not too concerned. Okay. So let's look at the next one. Like I said, these are going to be the types of examples that you'll see on the activity where I don't have anything outside of the bars. So we are good to just set up my two equations. One being 3 minus 2x equals 7. The other one being 3 minus 2x equals negative 7. And now I solve the same way. So we want to ask ourselves, what do I move away first? We always want to move the number not attached to the variable, the number that's being added or subtracted. This one's kind of tricky because you see this minus 2, but that minus 2 is not what we want to move first. This is a positive 3. So I want to subtract 3 from both sides, and I'm going to do that all at once. So make sure to bring down the negative 2x. 7 minus 3 is 4. Again, bring down the negative 2x. Don't forget that. Negative 7 minus 3 is negative 10. Now, what do I need to do? I can divide by a negative 2 on both sides. So x equals negative 2. Do the same thing over here. X equals positive 5. So there would be my two answers. I would have one number at, I don't know why I keep making those circles. Negative 2, 1 at 5. I guess I want to just color in the circles right away. I don't know. Okay, so let's try this one. This one, we have two things outside of our house, outside of the bars. I have a 2 and I have a 5. We want to follow the same process as what we just did. Move the thing that's being added or subtracted first. This 2 is being multiplied. It's squished next to the bars. This 5 is being subtracted. There's a minus sign in front of it. So we want to move the 5 first. We want to add 5 to both sides. So I'm going to just copy all of this down with the absolute value bar still. 21 plus 5 is 26. Now I can get rid of this by dividing. So I now have 2g minus 3 equals 13. Now that I have the bars by themselves, I can set up my two equations. One being 2g minus 3 equals 13. The other one being 2g minus 3 equals negative 13. We follow the same process. This minus 3, I want to move that first. Move what's being added or subtracted. I'm going to then add 3 to both sides. And again, I like to just get all of that done at once. So I'm just kind of used to that process of, okay, add 3, add 3, add 3, add 3. So I have 2g equals 13 plus 3 is 16. 2g equals negative 13 plus 3. That gives me negative 10. Now we can divide by 2. I know I'm running out of room. I get g equals 16 divided by 2 is 8. Negative 10 divided by 2 is negative 5. And at any point, I know I'm going kind of fast here through the solving part, but you can pause, use your calculator at any time if you feel like you do not know what any of this is. But I think we're getting better. We have practiced a lot with our multiplication, okay? So then I can graph negative 5 and 8. Again, you won't have to do that on the classwork. Okay, last one. Nothing outside of the bars. I'm good to set up my equation, all right? But I also want us to pay attention to something. What do we know? Can I have an absolute value equaling something negative? Hopefully you said no. Hopefully you're remembering this, where if I have just the absolute value bars equaling a negative number, equaling, not an absolute value, equaling something negative, this would be no solution. There's no number that I can ever plug in for p that is going to give me something negative. That defeats the whole purpose of an absolute value. Absolute value makes it positive. That is impossible. So we would say no solution. So hopefully you didn't work too fast and solve that one out. All right, so hopefully you're getting a little bit kind of used to, it's regular equations, just you're setting up two of them. So like I said, your examples are going to look like this, but these examples are a little bit more in depth. So if you were keeping up with these, then you should totally be fine for the classwork today. Again, you're working on those 6 problems. There will be a piece of paper given to you to show your work on. That needs to be turned in, as well as this paper. So this paper needs to be fully filled out. So if you need to go back and fill stuff in because you were just watching it and not writing anything down, do that. You need to turn this paper in, as well as the classwork paper. When you're done with those 6 problems, turn both of those into the pink box. Then you can work on something else. And I will see you guys tomorrow.